Dear students, now we are going to see deterministic finite automata. This machine we are going to see. So this is that 5-tuple automatic machine. It represents Q, finite set of states, sigma, finite set of input symbol, Q naught initial state, F final state, delta transition function. So deterministic finite automata is a 5-tuple function. So 1, 2, 3, 4, 5. So it is called as 5-tuple function. So the characteristic is every input symbol must go to the unique next state. That is determinator. We can predict the next. What is the next state? So that is the deterministic. We can determine, we can confirm, we can assure the next state. So here the initial state is Q0, final state F is Q2. When the input symbol is 0, from this Q0 to it moves to Q1. Again, when it gets the input symbol 0, it moves to Q2. So for the same input symbol 0, it doesn't go to another state. So for the same input, it doesn't have two different output state. So this is determinant. One input, one output. One input, one output. So this is deterministic finite automata. So the transition function is delta colon q into final state tends to that next state, which is equal to next state. What is written? Q, that is the next state. One input, one first state with a particular transition input leads to another state. So this is that. So from present state, based on the input, move to the next state. These are two different states, and for the same input, no two different output state is allowed. This is deterministic finite automata. Students, we are going to see non-deterministic finite automata. It means we cannot guess the next state for a particular given input. For a same input, we may have many number of next states. So for same input, we may have any number of next state. It is called non-deterministic finite automata. So multiple next state for the same input is possible. It is easy to construct NFA than DFA for a given regular language. So every NFA is not DFA, but NFA can be translated to DFA. So what is that presentation, or how the NFA is formed with a 5-tuple measurement Q, sigma, Q naught, F and delta. So we all know that. So let us see the example first. So it is given Q is the number of states available, the name of the states, that is Q naught, Q1, Q2. So 3 states we have given. The number of inputs is given as 0 and 1. So this is the input. So for every state we can supply 2 inputs. One is 0, another one is 1. So what is the beginning state? First state is Q naught. What is the last state or final state? Q2 is the last state. So based on this information, we have to construct the NDFA state transition diagram. How? So initial state Q naught, middle state Q1, final state Q2. For every state, we can have two different inputs, 0 and 1. So it is NFA. So for every input, we can have multiple levels of next state. So Q naught is supplied with 0, 1. It may take either to Q naught or Q1. When Q1 is supplied with 0, it goes to Q2. When Q1 is supplied with Q1, it goes to where? It goes to again Q2. So Q2 is supplied with 0 and 1. Or when Q1 is supplied with 1, it moves to Q1. When Q1 is supplied with 1, it goes to Q naught. So every input is supplied with 0 and 1, and we may have multiple sets of next state. So this is the state transition table. So what are all the inputs available? Language, we call it as the input symbols are called as the language 0 and 1. So what are all the states? Q0, Q1, Q2. Q0 is the first state, and a double circled state representation is the final state. So when Q initial state is applied with 0, we got two different next state. One is Q0 and one is Q1. So that is represented here. When a Q0 is applied with 1, the next stage is obviously we have Q1. So similarly Q1, coming to Q1. When Q1 is applied with 0, there are one possible outcome. Here it is represented, Q1 goes to Q2. When Q1 is applied with 1, it goes to Q0. So that is represented. Then third is Q2. Q2 is applied with 0 and 1. When it is applied with 0, the next state is Q2. When it's applied with 1, the next state is Q2 and Q1. So this is the state transition table for this NFA. Now we are going to see another three sets of example. One we have already seen. Now we are going to see the language beginning with 0 1, the language end with 0 1, and the substring 1 0 1. There are two steps. First one, what are all the input symbols? Input symbol is language is 0 and 1. So from this language, how many words we can frame, or how many combinations, how n number of constructions can be possible with this particular input 0 and 1. See here, the language we are constructing L. So it is beginning with the 0 1 0 1 0 1 0 1 0 0 0 1 1 1. So the any number, n number of words or n number of items or n number of diagrams, n number of output state can be drawn with beginning with the 0 1. So how to write the n, how to draw or how to construct this? So what is that states? We are having Q0 and the final state as Q2. What would be the first two states? Particularly 0 and 1 is the two consecutive state. So Q0 should get the input symbol Q0, it particularly moves to Q1. Then Q1 should get the input 1, it goes to Q2. So in every, this is the beginning machine. So every time this is the entry point. So it gets input 0, move to next state, get inputs 1, move to next state. So 0 and 1 is constant. So what is the next three letter? From the third alphabet or from the third point, we should have 0 and 1. Either it may be 0 or it may be 1. It is the loop. So we can either kept on moving any number of input medial symbol we can have. Finally, we may have 0 to, so 0 1 0 0 1 1. So this is the sample NFA we have drawn. I hope you understand. Now it ends with 0 and 1. So what is ending? So here it is ending, here it is the beginning, it is the end point. So in the beginning we may have any number of inputs, that is 0 1 is the basic NFA. So that is end with 0 1. So Q1 0, Q0 taking input 0, Q1 taking input 1, Q2. So what is the beginning? We may have 0 0. So in the beginning stage we should have the loop for 0. If we may have the loop for 1. So 1 1 also possible. So any number of zeros, any number of ones we can have in the beginning, but at the end it should go to 0 and 1. So this is that end with 1. Here any number of inputs at the end. So beginning with 0 and 1. So no one is admitted, no 0 is admitted in the beginning. Here here is no 0 is admitted, no 1 is admitted in the in the end. Here only it is allowed. Now substring. So what is the substring? We have substring 1 0 1. So in between the state is having the DFA 101. So 1, if we get the input 1, it goes to Q2. Immediately we should give the substring 0, it takes the next state Q2, and we should give the substring language string 1, it goes to Q3. So this sequence is the in between. So beginning also we may have so many inputs language, at the end also we may have language output. So we are giving the loop. So how can we have it? 0 0 1 0 1 0 0 1 0 1. So the end, so a substring, this is the substring, 101 is the substring. So it may be the substring we can have. So this is the example. So in the this NFA construction is very easy. For a given input we have multiple next state. So how to construct with the beginning or in the middle or at the end. Thank you.